When we're looking at the greatest common factor, or the GCF, we always want to look at what values there are within each of the terms. All right, so here, 21x cubed, if I think about the number 21, that is 7 times 3. Those are the prime components. Okay, and then x cubed is just the letter x multiplied 3 times. Here, when I think about 42, 42 is 7 times 6. So since 7's prime, I write it down. And then 6 is 3 times 2. And when I look at my last term, I get a 3. Okay? When I'm in those prime components, what I'm looking for is I'm looking for everything that matches. So I could see that each of these sets here has a 3 in it. So I would say that the GCF is 3. Now, when I want to factor out the GCF, what I do is I take a set of parentheses and I put everything that's left over. So any portion of the polynomial that I did not use. And I need to multiply that stuff back together. So 7 times 3 x's makes it 7x cubed. Here in the red, I see that I have a 7 and a 2 and an x. So 7 times 2 is a positive 14, and then an x. Now, here with the 3, I use up all of the numbers that are there, but I need some kind of placeholder. So the placeholder I'm going to leave there is a 1. If we have successfully factored out the GCF, you should have an expression that looks like the GCF times the leftovers, like that. And what you can do is you can actually distribute your GCF and go back to the original terms. Okay, so 3 times 7x cubed is 21x cubed. 3 times 14x is 42x. And 3 times negative 1 is negative 3. If I hadn't put that placeholder there, this negative 3 wouldn't exist and I wouldn't go back to my original term. So this is now the factored form. Now, one common misconception is that the GCF is just a number. You need to remember as you're working on this that GCF can also be a variable. Decided I don't like this being a 7. I'm going to change it to a 16 because why not? So when I do that, here we're going to break this up. 16 is 2 times 8, so I'm going to write the 2. 8 is 2 times 4, and 4 is 2 times 2. So 16 is 2 to the 4th power. Sorry, my pen is being a little bit of a bear right now. Now I also have x to the 5th, so I'm going to write the letter x 5 times. So now when I come here to the 4x cubed, 4 is 2 times 2. And then x to the 3rd is x 3 times. And here, well, 2x it's just 2x. So when I go to play my little game of Go Fish and I find what matches in each section, I see that there is a 2 in each of these. And I see that there is an x in each of these. So 2 times x is 2x. And then I'm going to gather the rest of my leftovers and multiply them together. So in the blue, I'm left over with 3 2's. So 2 times 2 is 4, times 2 is 8. And then there's 4 x's, so I call that x to the 4th. In my green here, I have a negative, and then 2, and then x times x is x squared. And again, I used up all my stuff here in the red, so I need to put a placeholder of +1. Now, it is common if you have a negative in front of your leading term, it is common to factor that negative out as your GCF. Okay, so the way that would look, for example, I changed to yellow. my pen will let me change to yellow. So what that would look like if this was negative, this was positive, and this was negative, you would have a negative for your GCF, and then these signs that are left in here would all change. Okay, so when I divide 16 by negative 2, that would leave me with a positive 8 here. A positive 4 divided by a negative 2 leaves me a negative 2. Did I mess this up? Am I crazy? No, we're good here. I switched all these other signs. Sorry, having a moment. So negative 2 times negative 2 here. By taking that negative out would keep that positive. Okay, so if you have a negative out in front, you divide the negative, and then you'll see these signs here on the inside all appear to flip. Okay, so check that out. Make sure your leading term doesn't have a negative in it anymore when you determine your GCF. And remember, your GCF can be a mix of numbers and letters.